show you how this goes then. Now, the way I do the unit circle on exam 3 is I give you the unit circle for exam 3, but I don't give it in the future exams, okay? So you want to start kind of working on learning how to memorize this. There is a video I put on Canvas that will run you through how to memorize this. It's not as hard as it seems, but on this exam, I just give you the unit circle, and then you'll be doing, you know, problems kind of like what we're going to start doing now. Okay, so what I want to do is just review what we did real quick last time. So basically, remember, if you want to find the sign is just the y value. So let me just kind of look over these ones that I did the sign on. So the sine of 45, you find 45 degrees, there's the answer. It's square root of 2 over 2. 4 pi over 3, you find the angle 4 pi over 3, which is here, and then the answer is the y value, like that. Sine of pi, again, here's pi, there's the y value. So that's all you do to find the sine of an angle that's on the unit circle is you look up the y value. That's it, piece of cake. Okay, and if you do a cosine, the cosine is the x value. So the cosine of 30, you find 30 degrees, you give me the x value. Okay, 11 pi over 6 is here. X value, square root of 3 over 2. Cosine pi over 2, give me the x value. So it's real simple. Cosine's x, sine is y. Everybody with me there? Okay, all right. Like I said, on this exam, I give you the unit circle, and I'll be asking you questions like this where you just quickly look on the unit circle and get that value. Okay, all right. Now on the next page, we'll go through the other trig functions and how you do these. Okay, so I'll just display this unit circle on here too. So really what you know is the secant is the reciprocal of the cosine. So let's focus on just doing these two secants right here. So what you would do is you'd have to find your angle. Now I can give you angles that they're going to terminate on the unit circle, but these are coterminal. So if you have a negative 270 degree angle, remember you're going clockwise, just count it out, 90, 180, negative 270. So the x value of that is 0. So that means this would just be 1 over 0 then. Okay, so the secant of negative 270 is 1 over 0. So what do you know about dividing by 0? You can't do it, right? So this one would be undefined. You're going to find that these trig functions are undefined at places where you divide by 0. Okay? If you did negative 210, and again, you'd have to kind of think about coterminal angles. You can do this in your head. It's clockwise, that would be 180, and then it would be 30 more to get to negative 210. So the x value is negative square root of 3 over 2. Whoops, hold on, I'm looking at the wrong, writing that down in the wrong place. So negative square root of 3 over 2, you just want to take the reciprocal of that, okay? So turn it upside down, and then that would be 2 over root 3. It's just a negative answer, and then you want to rationalize the denominator, which I've told you can do that in your head if you want to, right? So that would be the answer to the secant. So all you do is find the x value, reciprocal. That's how you do a secant on a unit circle. Okay, everybody okay with so far? Okay, all right, now if I do a cosecant is the reciprocal of the sine, therefore you just do the reciprocal of the y value. Okay, so if I was going to look at 270, let's see, 270 is here, the y value is negative 1, so if the sine of 270 is negative 1, then so is the cosecant because it's the reciprocal anyway. Just turn it upside down, okay? And then 225, you want to find 225, which is here. The y value is negative root 2 over 2. So what you'll do here is just do the reciprocal of that to get negative 2 over root 2. And then you want to rationalize the denominator, okay? So what that gives you is negative 2 root 2 over 2. 2's cross out, so that's negative square root of 2. Okay? So that's it. That's all you do to do a cosecant. A secant is look at the x and y value and do reciprocals. Okay, is everybody with me there? Okay, no questions? Okay, this is pretty easy to learn. Okay, now when you do a tangent and cotangent, you just have to apply the definition. So remember the tangent is y over x. So let's go through and do the tangent. So what you want to do on a tangent is you have to crunch out y over x. Okay, so if you go to negative pi. Negative pi would be 180 degrees clockwise, so you would be at that point right there. So the way to work this out then would be y is 0, x is -1, 0 over -1 is 0. Okay, like that. So you have to actually crunch out y over x when you do a tangent. Okay, if we do tangent of pi over 2, pi over 2 takes you to this point. Y is 1, x is 0, so what's the answer? That one's undefined, okay? And that will happen. You'll get undefined on a lot of these problems. You won't on the sine cosine. Sine and cosine are always defined, but the other 4 trig functions have places where they're undefined. Okay, and then the next thing we're going to do is the cotangent is x over y. So we just kind of approach this the same way. So cotangent of pi over 6, you find pi over 6, and then you form that ratio. So you would have square root of 3 over 2, all over 1 over 2, and you can just reduce out those 2's like that. So you end up getting square root of 3 over 1. So the answer of that is square root of 3, okay? Right, and if you do the cotangent of -2 pi, well, that would mean clockwise 1 lap around the circle, so you would be there. So the cotangent would be x over y. That would be 0 over 1. Nope, no, teacher. 1 over 0. Okay, so x is 1, y is 0. So that's undefined like that. Okay? All right? So again, just to kind of summarize this, the sine and cosine are the sine is the y value, cosine's x. Secant is reciprocal of x, cosecant's reciprocal of y. Tangent, y over x, cotangent x over y. So it's real easy if you're given a unit circle to figure these out. All right, is everybody with me okay? Any problem? Okay, so that's kind of what we're getting from the unit circle. All right, like I said on exam 3, I'll give you the unit circle, but I won't after that because you want to start taking some time to get that memorized, okay? All right, next thing we're going to look at is some new identities. We haven't talked about even and odd identities yet. So I'm going to talk about that. I'm going to review what we did earlier this semester because we learned about even and odd functions. So we learned that an even function, a function's even if f of -x equals f of x. Now what that means to me is this, okay? I mean, you can write this down if you want to. Like if you had a point, say 2, 1, on an even function, then if you changed the x, well then y wouldn't change. You would end up just kind of having the same y. So think of an even function as when x is opposite, y doesn't change, okay? An odd function works like this. This says if f of -x is negative f of x, so you can write down this example if you want to. So let's take the same point 2, 1. Well, if you change x to negative, then y would be negative also. So what happens on an odd function is when x is opposite, y is opposite. Okay, so we learned that earlier in the semester. And trig functions follow this pattern. Some trig functions are even, some are odd. Okay, so this is kind of an example. An even function, remember that one was symmetrical about the y-axis. Okay, that's an example of an even function, the parabola you see. And then an odd function, how did we say the odd function was symmetrical? Origin, right. Okay, good. So that one is origin symmetry, like that then. Okay, so we're going to do on the next page is kind of a quick review, because I think it'll help you understand the trig identities better, because here you're going to have more identities that you got to remember. And I don't give you these basic fundamental identities, so you got to know them. So, but it's easier if you understand, then you can just build the identities as you go, okay? All right, so mostly on this page, next couple of pages, we're just going to do kind of a quick review here, all right? Let's see what we remember on this. Okay, so let's say we have the point 3, 4, and you have an even function. So what would be the -3, what would y be if it's even? What happens to y? Nothing. It stays the same. Good. Okay, so if it's an even function, then that happens. Okay, same thing on this. If you have a general point xy, okay, then if x becomes negative, you have the same y. Okay, so that's kind of what I like to emphasize when I'm teaching that. Okay, odd functions work like this. So if -2, 4 was on the graph, then 2, -4 would be on there. So the key thing on that is the y's are opposites on an odd function, okay? And in general, if you had xy, then you would have the point -xy like that, okay? And that's kind of it, all right? Everybody remember this reasonably well, okay? What kind of function do you think this one is? Example 2, even, odd, or neither? How's it symmetrical? It's symmetrical about the origin, so that means that's an odd function, right? Okay. And I mean, you can write this point down if you want to, but so see, that's a point 1, 1. Notice there's a point -1, -1. Okay, that's what you expect to have in an odd function. Okay. How about the next one, even or odd or neither? What do you think? That one's even, right? Because that one's symmetrical about the y-axis. And notice on this one, I don't know, I'm going to just kind of pick a couple of points and maybe estimate. I can't even see this very good, but that point might be the point 0.5. Okay, so notice that you would have a point over here, -0.5, but the y value would stay the same. Okay, so that's the idea. Okay, symmetrical about y. And then the next one, what do you think about this one? Has that got any symmetry? No, there's no symmetry, so that's would not be an even or odd function. Okay? Okay, all right, let's go to the next page, and I'm going to just do this. I want to make sure that you have this really well established in your mind, because when you do the trig functions, you want to not memorize the identity, you want to just make them if you understand how this works then. All right, so let's just do a quick sketch on this. I went ahead and just made a table of values on this. This is a parabola that's going up 1, so just plot the points that I gave you. I don't want to take the time to do that. So you have -2, 5, -1, 2, 0, 1, 1, 2, and I think that's number right there should be 2, 5 is what I think I meant on that. All right, so is that an even function or an odd function? Just by looking. That's even, right, okay. All right, so basically you can think of this in 2 ways. It's symmetric about the y-axis. All right, the other thing is, notice how when x is opposite, notice how the y's stay the same. So you got -2, 5, 2, 5, -1, 2, 1, 2. Okay? All right, next one, let's see, plot this. We learned how to do these things too. This is just kind of an overview and refresher here. So if you plot these points, have a function like that, is that odd or is it even? That one's odd, okay? And one way to look at this is, this one is symmetric about the origin. Okay, that's good enough if you write that on there then. And then notice that the y values are opposites when x is opposite. Okay, that's the key thing, all right? Okay, so enough of that. The key thing is an even function, opposite x, same y. Odd function, opposite x, opposite y. All right, so we're going to think about that when we do the trig, and I'm going to show you kind of these identities and how you build these then, okay? And I'm going to use the unit circle. The unit circle is kind of like the trigonometry god. I mean, it tells you everything. I mean, all the identities are in there. It's just everything is wrapped up in that amazing diagram there. I'm not kidding about that. All right, so I want to show you something on this. Let's look at, you don't need to write this down, just pay attention to this. What would be the sign of 30? That would be a half, right? Okay. What would be the sign of -30? Just look at my unit circle. What would that be? Yeah, you would go clockwise, so that would be -1/2. Now, does that follow a odd function pattern or an even function pattern? Just what I did right there. That's, no, not even. When I have opposite x, I got opposite y. That's odd, okay? See, that right there shows you that you have an odd function there. That's the idea. Okay, let's do cosine. Cosine of 30 degrees. What's the cosine of 30 degrees? That's square root of 3 over 2. What is the cosine of -30 in my unit circle? It's the same, isn't it? Okay, it's the x value, okay? So what do you think a cosine is? Does that look like it's odd or even? That's even, okay, because opposite x gives same y. So you can tell if a trig function's odd or even by looking at the unit circle and just doing an example of a couple of angles. So here's basically what you have. you have the even trig functions. You want to write this down. Just the cosine is even, and so is the secant. And that's just because the secant's the reciprocal of the cosine, so it works exactly the same way. All right? All right, the odd trig functions are the rest. So you would have the sine, and you would have the cosecant, and then you would have the tangent, and you would have the cotangent, since they're reciprocals. So one way to remember these identities, and if you forget which trig function's even and odd, the unit circle will tell you which one's even or odd. That's what I was trying to show you over here. You can easily figure that out, say, okay? So here's how the identity goes then, and this is what you have to remember. If you do the cosine of negative x, then it stays the same. Okay, it's just the cosine. If you do the secant of negative x, it stays the same. So if you want to write a note, this is a good thing to write down, like I've been emphasizing. Opposite x, same y. Okay, so the function doesn't change. If it's an odd function, when the exponent, or not the exponent, the argument is negative, then so is the sign. So it's opposite x, opposite y. So all of these things right here have that approach. Opposite x gives opposite y. Okay, so you got to know those trig identities, but if you understand them, it's not hard to remember them. That's how I remember all this stuff, is I understand what even and odd functions are, and I know which is which. Okay, and if I forget, I just look at the unit circle and figure it out. Okay, that's what you want to do in higher math, is figure stuff out, okay, instead of memorizing a bunch of stuff. All right, so that's what you need to know, is those identities. So is there any question about how those identities are written? Okay, it's kind of the same thing we've been talking about. It follows that same pattern, okay? All right, so let's see. This kind of stuff I'm not going to go over too much, because I really showed you on the unit circle. This is just stuff I gave you to look at. So we've kind of established that. I don't think I'm going to probably do anything on this. It's just, this is really showing this real quick. So like for instance, if this is theta, then you have a cosine. Cosine of theta is just the x value. Okay, if you do negative theta, then you just end up getting the same thing. The cosine of x, or cosine of theta, would still be x. Okay, so the idea is real simple. It's on a cosine, they're both going to have the same x value. If you do an angle and a negative angle, x is the same. The sine is the opposite. The sine is a y value, so you have a positive y there and a negative there. That's how you can look at that unit circle real quick and figure it out. Okay, the tangent's the same thing. It would work the same way as the sine then. Okay? All right, I'm not going to do anything on that page, I don't think, so let's just move on from here, and I want to work out a few other problems here. Okay? Let's see. Yeah, I'd rather just do this, okay, and just show you a little bit different way. So let's go through on this, and let's draw a triangle, since we've learned the 30-60 triangle. So let's just do like a 30-degree angle there, and go ahead and just go straight down the bottom, okay, like that at a right angle. So you have a 30-60 right triangle. Okay, you guys remember how the sides go on a 30-60 triangle? It's as easy as 1, 2, 3. 1, 2 square root of 3. All right, and it goes like this. Okay, and you got to match them up in the right place. 1 is the smallest number. 30 is the smallest angle, so you get a 1 there, and that would be a y value. You'd have y equals 1. Okay. 2 is the hypotenuse. 2 is the biggest, so that would be the hypotenuse. So that would be r equals 2 in your diagram. And then the 1 in the middle is the square root of 3, so your x value would be square root of 3. Okay, so actually what you would get in this diagram then is you would have a point, and that point would have an x value of root 3, y value of 1. So you're going over root 3 up 1 like that. Okay, so just going to show this to you real quick. It's just kind of a diagram. Let's do the sine of 30. Let's do the cosine of 30. And let's do the tangent of 30 degrees like this and just see what happens to begin with. All right, so the sine is, remember SOHCAHTOA, the sine would be opposite over hypotenuse, so that would be 1/2. Cosine of 30 is adjacent over hypotenuse, so that's square root of 3 over 2. Okay, and then the tangent would be opposite over adjacent, that's 1 over root 3. Okay, I'm not going to worry about rationalizing that because I'm just trying to show you a point on this then. Okay, well, okay, let's also do this. Let's do the sine of negative 30, the cosine of negative 30, and the tangent of negative 30. Okay, and what would happen on this then is if you did this, you would still get a reference triangle. You would still think of this as a 30-degree angle, but you're going clockwise. So you would end up basically having this triangle here. And the only difference would be y wouldn't be 1, y would be -1. But x would still be the same. So what you would have is you would actually have a point that would end up being square root of 3 and then -1 like that. Okay? So what would happen in this triangle is the sine would be opposite, -1 over hypotenuse, so that's -1/2. Cosine would be adjacent, square root of 3 over hypotenuse, so you would get that. And then the tangent would be opposite, -1 over adjacent, -1 square root of 3. All right? So hopefully this would make sense to you. Okay. Notice that when the angles are opposite, so are the answers to the sine. That's an odd function, right? That's what you expect. Tangent, odd function. When the angles are opposite, so are the answers, okay? And then the cosine's even because the answers turned out to be the same. So you can do that kind of verification with a triangle too. That's just another way to look at that. And then the reciprocals are all the same. So what you want to remember is cosine and secant are even. The other 4 are odd, and then you can build your identities if you understand what an even and odd function is then. Okay? All right. Okay, so let's take a look at this then. This is just kind of a real quick, simple way to check students' knowledge on this. So on this one, I'm not giving you the angle because it doesn't matter, but if I gave you the sine of theta is 0.6, what would the sine of negative theta have to be? I've got a 50-50 chance. It's either 0.6 or -0.6. Which is it? Huh? Negative. It's an odd function, right? The sine is an odd function, therefore it's -0.6. Okay? All right. The next one. If the cosine of theta is 0.25, what's the cosine of negative theta? Which is it? It's the same, exactly, okay? Because that's an even function. That's it. You don't need to know what the angle is. It doesn't matter, okay? How about the next one? Tangent's -2.5. What would you expect tangent of negative theta to be? Same or opposite? Opposite. Okay, that's 2.5. That's because the tangent's an odd function. Okay, all right. How about the next one? Secant. Same or different? Same. Okay, it's an even function. So once you know which functions are even and which ones are odd, then it's easy. Okay. And then the last two go like this. The cosecant is odd. That's an odd function. So that means the answer would be -7.1. The cotangent's also an odd function. So the answer would be the opposite or just 3. Okay, like that. Okay, real simple. Okay. Probably do something like that on tests. That's an easy, quick thing to check students on. Okay, a quick way to see if you know what the difference between the two is. Okay, fill out the next two real quick, and or the next 4 real quick. All you got to remember is secant and cosine are even. Everything else is odd. And if you remember that, then you got it down. That's why I remember it. You actually will remember this better once we learn how to do the graphs, or kind of work on the graphing of trig functions today too. And get that going. That'll help you a little bit. All right, so here's what you should get. Number 1, the answer should be the same because it's an even function. Okay, number 2, it should be opposite because the tangent is an odd function. The next one should be the opposite, because the sign is an odd function. And then the last one should be the same, because it's an even function. Okay, that's it. All right? All right, are we solid? Okay, you want to understand this stuff instead of memorizing it. Students make a lot of mistakes a lot of times because they just memorize stuff too much in a math class. All right, so that'll wrap that up. Now, I'm